Good morning, students. Now, Mr. Tan and I myself, this semester we want to try out something new to help you. We are going to conduct our remedial lecture to help you in the retest. But this remedial lecture, we are going to video record it and put it in mail so that you can view them as you prepare for the retest at home. There's no need to come and make special arrangement to see lecturers. Now, we'll start with the second topic, the single-phase AC transformer. Now, transformer is a very big topic, and we are going to break it into parts so that you can see the relevance of things in perspective. Now, basically, transformer, if I were to summarize it, the knowledge that we want you to know can be broken into 4 parts. Yeah, one is the transformer basic, and for this one, is basically consists of a lot of basic formulas. 2, referring of parameters. Alright, and 3 is the open circuit and short circuit test. And 4 is voltage regulations. So these are the 4 parts that is covered in transformer that we want you to know. But voltage regulation is just for appreciation only, because in the exam, we will not set exam questions on that. So we'll now move on to 1, 2, 3, and 4. Okay, let's start with transformer basic. Alright. Now for transformer basic, the first thing that you need to know is that how to draw an ideal transformer. An ideal transformer consists of an AC source with primary circuit and a secondary circuit, right? This is called the primary coil, this is called the secondary coil, and this is the AC source, and this is the load. Now, so transformer consists of primary turn, secondary turn, primary voltage, and secondary voltage. Now, sometimes you see that we use V and E quite, should I say, interchangeably. It's fine. If you call here V1, it's fine. You call here E1, it's fine. Alright, but basically it means it's a primary voltage, secondary voltage. And of course, you have primary current and secondary current. So that is the ideal transformer. Okay, there's a diagram of ideal transformer. Now, in terms of the real transformer, the diagram actually looks like this. It consists of an iron core, and then we wrap around wires, and that is called the primary wires, primary winding, and we put our AC source, right? And then the secondary winding, and then this is the load. So this is the construction of a transformer. But in terms of electrical diagram, this is the one, ideal transformer. Alright? Okay, now we then move on to the second point, which is called the turn ratio. Now, turn ratio is, we call it A, right? And A is equal to N1 over N2, V1 over V2, I2 over I1. Now, turn ratio, when you ask for a turn ratio, it must be presented in primary turn divided by secondary turn, primary voltage divided by secondary voltage, and secondary current divided by primary current. Cannot be any other ways. Must be this way. Right? Now let's practice, because students always find it a bit difficult is that to recognize who is primary, who is secondary. Now if I were to give you a transformer diagram, alright, and I say that this is 240 volts and this is 600 volts, right? Now the diagram that shows the power supply, that is the primary. So in this circuit diagram here, the turn ratio, right? The turn ratio is equal to V1 over V2, which is equal to 240 divided by 600. And turn ratio has no units. Turn ratio has no units, right? Now, if my diagram is presented in this manner now, I connect my power source here. I connect my power source here, right? And this is my load. For this diagram, the turn ratio will not be 240 divided by 600, but 600 divided by 40. Why? Because my primary now is 600 volts. 600 volts. That's how you solve turn ratio. If you are given a diagram, it is very easy to visualize. Now, what if I don't give you diagram now? If I don't give you diagram, but I give it to you things like that, I say this is a 10 kVA transformer, and it is 440 volts versus 1050 volt transformer. Right? I give it like this. And then I say this is a step-up transformer. If I were to use it as a step-up transformer, then the turn ratio is V1 over V2. Who is V1? Step up, the small one is a primary. That means you fit in a small voltage and you get a high voltage at the end. So therefore, V1 is 440 and V2 is 1050. So that is a turn ratio if it is working as a step-up transformer. But if I change the question now, I want it to be a step-down transformer. Step-down transformer. Then the turn ratio again is V1 over V2. Then you ask yourself, who is the V1? Who is V1? Is this V1 or is this V1? Because it's a step-down transformer, so this is the V1. Yeah? So this is 1050 divided by 440. Okay? So we learn that in turn ratio, the formula is N1 over N2, V1 over V2, I2 over I1. Right? And make sure that we are able to recognize who is the V1. You can recognize the V1 by visualizing the diagram. Where is the power source connected to? If this is a step-up transformer, I feed in a small voltage. So this is my primary. If this is a step-down transformer, I feed in a high voltage. So this is my V1. Alright? So that is turn ratio. Alright, the third point is a very useful formula in transformer, which is called S equal to V times I. Alright, you learned that in Echem as well. Apparent power is equal to voltage times current. Apparent power is equal to voltage times current. So, current therefore can be calculated equal to S divided by V. Now, for example, I have a 10 kVA transformer. Alright? And the voltage is 240 and 600 volt transformer. Right? Now, of course, this is the apparent power. Apparent power. And this is the low voltage. And this is the high voltage. High voltage. If I were to ask you, hey, find me the low voltage current. Use the formula. Current is equal to power divided by voltage. Then you ask yourself, which voltage do you use? Right? The voltage you use should be the low voltage because you are finding the low current. So that will be equal to 10 kVA divided by 240. If we are asked to find the high voltage current, it's S divided by V. So it's 10 kilo divided by which voltage are we going to use? We are going to use the high voltage. So that is 600. Alright, so that is called the way that we find current using formula S equal to V times I. S equal to V times I. Okay? Okay, let's practice one more example using S equal to V times I formula. Now, I have a 12 kVA transformer and the voltage ratio is 500 and 1300 volt transformer. Okay, and now I'm asked to find me the high voltage current. Then you remember that to find current using S equal to V times I, So I equal to S divided by V. So that will be 12 kVA divided by V. Which V? HV. Yeah? So that is 1003. Okay? And find me the low voltage current. S divided by V, LV. So it's 12K divided by 500 ampere. Right? So that is called the apparent power formula. S equal to V times I. Okay, let's try the next point. Now the next point is about if I'm giving you a transformer and I'm asking you to find parameters, it's accumulation of knowledge of 1 and 2. Okay, let's try. If I have a transformer diagram, okay, and I say this 240 volt, 600 volt transformer, all right, then I say that this is equal to 4 kilo ohms. 4 kilo ohm. So this is I1, this is I2. I1 and I2, right? If I were to ask you to find I2, are you able to find? Yes, because you know that here is 600 volt, right? And the voltage here, of course, is also 600 volt. So I equal to V over R, and the V is 600, and the R is 4 kilo. So you are able to find I2. You are able to find I2. Then I move on and say, find I1. Right? If you know I2, can you find I1? Yes. Because you remember the turn ratio gives you the method. Yeah? What is turn ratio? Turn ratio say V1 over V2 equal to I2 over I1. Alright? Be careful when current comes, it flips over. I know V1, I know V2, I know I2, I do not know I1. Can I1 be found? Of course can be found. Alright, so sometimes we also use turn ratio to find the unknown current or unknown voltage, or even unknown number of primary turns. Okay, so that is the fourth point. If you are given a circuit, right, when current is not given, but you know the voltage, you know the load, you are able to find current. If you know one current, you can find the other current as well. Alright, let's come to our last point in transformer basic, which is a physics formula. A physics formula say E1 is equal to 4.44 Fn flux. Right? Or E2 equal to 4.44 Fn2 flux. Now this is the primary voltage. This is the frequency of the AC power supply. This is the number of primary turn. And that is the flux that links the transformer from primary to secondary. Remember? We say transformer, we have primary coil, secondary coil, right? Now, when this becomes a magnet, there's a flux that's linking the primary and the secondary. So this is, we call them the flux. The flux. So if the question gives it to you that concerns flux, right? Then you know that there's no other formula except this formula to use. Okay, let's illustrate. I have a transformer that is 50 Hertz transformer, and the number of primary turn is equal to 650 turns. 650 turns, and the voltage ratio is 400 and 840 volts transformer. Okay, and you're asked to find what is the maximum flux that links the transformer? When this information given to you, you know for sure that you need to use this formula. Now, which one to use, of course? You look at the information, you're given the primary turn. So, of course, it's the first one. Right? So, we'll say E1 equal to 4.44 Fn1 maximum flux. Okay, what's E1? 400 volts, 4.44, frequency is 50, N1 is 650, and maximum flux, that's the unknown. Right? So therefore, flux can be found. Flux can be found. Alright, the units of flux is Weber. Got it? So this is called the physics formula. Likewise, if I change the question now, right? Instead of giving you N1, I say N2. N2 is equal to 900 turns. Okay? And I do the same thing and ask for the flux. What do? This time, instead of using the primary turn, the primary voltage, you should use the secondary voltage because you are given the secondary turns. So you will say E2 equal to 4.44 Fn flux, right? So E2 is equal to 840 volts. Frequency is 50. N2 is equal to 900. And that's the maximum flux. One equation, one unknown, so the flux can be found. Got it? And that is the transformer basic. Let me check if I missed out anything. Oh, there's one more, which is called the fraction of full load. Yeah, that's point number 6. Point number 6 is about fraction of full load. Yeah. Now I have a transformer, 10 kVA transformer, but it doesn't mean that every time when I use my transformer, I use it up to the maximum capacity. So if I say I only want to use 60% of full load, that is basically means the fraction of the full load is 0.6, 60%. So in other words, the power that I'm consuming, he's able to give me 10 kVA, but I'm only going to consume 60% only. Yeah, so that is 0.6 times 10 kVA. So I'm only using 6 kVA. That's the meaning of fraction of full load. Now, what are the possible questions that people will ask you for fraction of full load? It's the same thing as what we learned before to find current. For example, I have the voltage ratio here is 400 to 940 volt transformer. Okay, and I say find me the low voltage current. Now you recall that current is equal to power divided by voltage, right? And then you say here divided by low voltage. Right, fine. Low voltage you use 400. But how about the power here? In this question, are you going to use 10 kVA or 6 kVA? The answer is 6 kVA. Because in this question, I'm not using my transformer to the full. I'm only using it as a fraction of full load, a fraction, a part of it. And in this case here, only 60%. Alright? So let's practice on finding the high voltage current then. Right, if I were to find the high voltage current, I will say S divided by V. Right? Again, we ask ourselves, in this question, the power I should use 10 kVA or 6 kVA? The answer is you should use 6 kVA because we are using only 60% of the full load. So it's 6 kVA divided by 940. Alright, so that is the transformer basic, the 6 point. Okay, let us summarize it by going through some simple examples. Okay, let's go through some simple example of questions that integrates all the knowledge that we learned so far. Right, so if I have a 20 kVA transformer and the voltage ratio is 800 and 1500 volt, and it operates on the fraction of full load of 0.7. Right? Okay, part A. What is the turn ratio? Part A asks for turn ratio, and it's working as a step-up transformer. Okay, turn ratio. Turn ratio is A. So of course, you are going to use a formula V1 divided by V2. Now this is a step-up transformer. So who is the V1? The smaller voltage, right? So you'll be 800 divided by 1500. So that will be your answer for the turn ratio. Part B, if I were to say that I'll give you more information, this is a 50 Hz transformer, right? And the number of turns in the primary is equal to 2000 turns. Okay, can you find me the flux that links the transformer? Right, part B. Then you say, oh yeah, this is the only one that is the physics formula, right? So if you want to use the physics formula, you say E1 equal to 4.44 Fn1 maximum flux. Okay, why don't I use E2? I can, provided I know N2, right? But in this question, I'm given N1, so it's logical that I should use this one. So who's E1? Who is the primary voltage? 800. So 800 equal to 4.44, frequency 50, N1 is 2000, and flux is an unknown, right? So this can be found. So that's part B. Part C. You ask, A, what is the load that's being consumed? What's the load being consumed? This is the maximum, but are we using the maximum? No, we are using only 70%. So the fraction of the load is 0.7 times 10 kVA. Right? So that is 7 kVA. Right? Part D. Find me the low voltage current and the high voltage current. Right? Then you say, okay, I use the formula S divided by V. S divided by V. Okay? Are you going to use the 20 kVA or the... Oh, Mr. Lee made a mistake. It's 20 kVA times 0.7. So it's 14 kVA. So in here, are we going to use 20 kVA or 14 kVA? The answer is we should use the 14 kVA because in this question here, we are not using the maximum, right? So it's 14 kVA divided by low voltage 800. 14 kVA divided by 1500. Okay, so that's part D. Right, last part. Part E. If I were to ask you, hey, find me the maximum current. The meaning of rated, alright, in electrical engineering always means maximum. So I say, okay, by fraction of load you found out the current already, but I ask you, hey, for this transformer, what's the maximum low voltage current? Then of course you see S divided by V again. But this time you should use the maximum S, isn't it? Because I'm asking you for the rating, what's the maximum? So you use the maximum S. So that will be 20 kVA divided by 800. Right? If I ask for high voltage rated, same thing, S divided by VHV. The S, you are going to use the maximum S. Rated, you must always use the maximum. So maximum. Alright, so that is all the points about the first part of transformer, the basic. Okay? Alright. Now let's wrap it up on the transformer basic. Are you able to draw the ideal diagram, ideal transformer diagram? Do you know what's the definition of turn ratio? Do you know what is how to use the physics formula to calculate the maximum flux? And do you know how to use S equal to V times I to find the low voltage current and the high voltage current? And lastly, when the question says that a transformer is not is working on a fraction of a load, will you be careful enough to use the so-called the fraction of the full load instead of the maximum power to do your calculations? Okay, that is the basic of transformer.